I am Shija, Assistant Professor, Department of Computer Science and Engineering, Savitha School of Engineering. In the last session, we have seen about the binary search tree algorithm and how to find the optimal solution in binary search tree. In this session, we are going to see about how to search the element using dynamic programming concept. So, we will use a key element and frequency for using the concept dynamic programming. The key element which we have considered in the example is 10, 20, 30 and 40, and the frequency for key 10 is 4, 20 is 2, 30 is 6 and 40 is 3. Then by using this key value and the frequency value, we have to create a table. In the table, we have to compute the optimal value and we have to store the optimal value in the table. Here I is considered as the row and j is called as the column. In key there are 4 elements, but while entering in the table we have to mark the first element as 0, then 1, 2, 3 and 4. Likewise in frequency also we have to start with 0, 1, 2, 3 and 4. Now we can move on to the first step. For computing the values in the table, we have to use the formula L is equal to j minus I is equal to 0. That means if we subtract any two values, you should get the resultant as 0. So if we subtract 1 and 1, we will get 0. Likewise 2 minus 2 0, 3 minus 3 0, 4 minus 4 0. Then we have to find the cost. Then cost of 0 comma 0 comma cost of 1 comma 1, then cost of 2 comma 2, cost of 3 comma 3, cost of 4 comma 4 we have to calculate. So all these values is taken as 0. So the diagonal value 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3 and 4 comma 4 is filled as 0 in the table. Then we can move on to step 2. In step 2, L is equal to j minus I is equal to 1. That means if we subtract two numbers, you should get the resultant as 1. So 1 minus 0 is equal to 1. 2 minus 1 is equal to 1. 3 minus 2 is equal to 1. 4 minus 3 is equal to 1. From this equation, we will write 0 comma 1, 1 comma 2, 2 comma 3 and 3 comma 4. So in the first step, we have filled the diagonal element as 0. The remaining element we have to compute in each step and all the elements will be plotted in the table. Here 8 power 1 represents the root. Here this 1 represents the root. Here 20 power 3 represents the root. Root the cost of 0 comma 1, C of 1 comma 2, C of 2 comma 3 and C of 3 comma 4. Here 1, 2, 3, 4 is considered as the key. The first key, value of first key is 10, second key is 20, third key is 30 and the fourth key is 40. The frequency associated with the key is 4, 2, 6 and 3. So we have marked the diagonal element as 0 in the table, and after that, after the diagonal element, we have to make this entry in the table 4, 2, 6, 3. Then we can move on to step 3. In step 3, L is equal to j minus I is equal to 2. So if we subtract two numbers, we should get the value as 2. So 2 minus 2 is equal to 2, 3 minus 1 is equal to 4 minus 2 is equal to 2. Here 0 comma 2, 0 comma 2, 1 comma 3, 2 comma 4. In this method, there are two possible keys. There are two possible keys. So that is C of 0, 2. So this is the first key. In the first key, the value is taken as 10 and 20. To compute C of 0, 2, the key to be considered is 10 and 20, and the frequency count associated with is 4, 2. The total frequency count is the combination of 4 and 2, that is 6. Now we can see the possible binary search tree for the two keys. So 10, 20. We know the cost for 10, 1, and 20, 2. The frequency count for 10 is 4. The frequency count for 20 is 2. So 4 plus 4 is equal to 8. Likewise, we have to calculate for the next possible binary search tree, 20 and 10. Now we have to compare the value of both binary search tree. Here 8 and here 10. 8 is the minimum one. So minimum is 8, and this is considered as the first key, and this first key forms the root. So in the table we have to fill 8, and for 8 the root is considered as 1. So in the table we have marked as 8 power 1. This is the shortcut method for computing the optimal value. Now we can try this by using the formula. W of 0, 4 is equal to sigma I is equal to 1 to 4 sigma Ri. In this formula we will substitute this value, C of 0, 0 plus C of 1, 2 plus W of 0, 2. We will get the value of 8. Since both value is similar, the computation part done by us is correct. Then we can move on to C of 1, 3. C of 1, 3. Here the keys is 20 and 30, and the frequency count here is 2 and 6. In the as previous steps, here also we have to find the possible binary search tree. Here there are two possible binary search tree, 20, 30 and 30, 20. For these two we have calculated the value 14 and 10. Here 10 is the minimum value, and this value forms the third key of, this is the third key, and it becomes the root. Then we can move on to C of 2, 4. In C of 2, 4, we need to ignore 2, and we have to take the third key, because since we have did the second key already, that's why we are ignoring the second key and we are taking only the third key. So 3 and 4, so the value is 30 and 40. Frequency count is 6 and 3. As like earlier method, we have to compute the binary search possibilities, and we have to find the minimum element. Then we have to calculate C of 0, 3. The value of C of 0, 3, we have taken the keys 10, 20 and 30 frequency count, and here we haven't used the binary search tree method. We have used the direct formula substitution method. So in the direct formula substitution method, we have added all the frequency count together and we will get 12. Then in the formula we have substituted the values and we got the value as 20. So that will form as the third key. Then C of 1, 4, W of 1, 4 is equal to 1. Here also we have used the formula, and in this formula we have substituted the values and we have computed the value of W of 0, 4 as 15. All these values are plotted in the table. Then by using the tables in the values in the table, we have constructed a binary search tree. So here 3 is taken as the first key and it forms the root of the binary search tree, and this is the root element here, and here the root element is 1, and here the root element is 4, and here the 2. Then for 3 the value is 30. We have replaced in the value of root 30 10, 40 and 20. So this is the optimal binary search tree. So to find the optimal binary search tree, we can use some formulas also. The formula for finding optimal binary search tree is C of I comma j is equal to minimum of C of I comma k minus 1 plus C of k comma j plus W of 1 comma j. Thank you.